Hello. Now we are going to discuss about programmable logic array. So here basic concept behind PLA is that here AND array and OR array both are programmable. So this one we are trying to design with the help of two functions. So this function has three variables A, B, C, and corresponding mean terms are given. And situation is given that we have to design with the help of four AND gates only. So first of all, we are going to represent the given main terms in the K map. So here we have three variables. So we have 8 boxes in the K map. So already we have arranged the boxes and corresponding mean terms are located here. For the first function, mean terms are 3, 5, 6, 7 that we have located. For the second function, so this one is for the F1 and this one we are going to give this K-map for the F2. So for the F2 corresponding functions that mean terms are given 0, 2, 4, 7 that we have located. Now, since here it is given condition that we have to do with only 4 AND gates. So we should be careful that how we are going to select the mean terms, whether without taking complement, we are able to get the 4 product terms since AND gate represent the product terms. So if you see the overview of this overlook of both K-map for F1 and F2, we are seeing that we don't have any common combination here. So number of the product terms are more here. So now in this case, we have to take the complement of any one function, or sometimes we can do F1, F2 without complement. Again, we can do with complement for F1 and with complement with F2. Then we'll see the which combination is going to give us 4 AND gates. So here for function F1, we are going to take the complement. So which mean terms are not given, for that we are writing the 0. So that we can take the complement of the function. So once this 0 is marked in the K-map, now we have to make the combinations, whether pair is possible or what are the maximum combination, better combination is available that we can locate here. Now, first we are making one pair here with the mean terms 0 and 1. So if you look here in the row wise, common is A dash, whereas column wise common is B dash. So that product term we have here A dash, B dash. Now another combination, again we have one more pair there itself. So this having mean terms, if we take 0 and 4 mean terms, one more pair we are going to get here. So row wise we don't have common, we have common here column wise. So that is the B dash, C dash. And third possibility is we are saying that one more combination we have here, that when we are going to include the mean terms 2 and mean term 0. So for this again, row wise we have common, that is the A dash, and if you will observe in the column wise we have common, that is the C dash. So finally this complement function F1 dash we are getting as A dash, B dash plus we have B dash, C dash plus A dash, C dash. Now we know that complement of the complement give the number itself. So here if you see that we have F1 complement, again we'll take the complement. So we are going to get here F1, that is going to give us now complement of this function A dash, B dash plus we have B dash, C dash plus A dash, C dash complement. So now here we are able to obtain this function F1 here. Now similarly we look for the F2. So in the F2 again, what are the pair is possible? What are the things? So here if you see that again this mean term 0 and mean term 2 is going to give us one product term. So row wise common is here A dash, column wise common is here C dash. So we have A dash, C dash. Another, if you see here in this case, so again we have pair of the mean term 0 and 4. So row wise we don't have anything common here. Column wise we have B dash, C dash. And finally, here we have one term that is the mean term 7, which is isolated. There is no neighbors. Adjacent neighbors are not there. So for this row wise, we have A and column wise we have BC. So we are getting again three product term here. So F2 is written as A dash C dash plus B dash C dash plus ABC. So now if you see that F1 and F2, so this is the one product term. Now we have another product term is A2 C dash, which is common in both. And third product term is B dash C dash, which is common in both. And fourth one we have ABC. So like this, we are able to obtain four product terms. So now we can implement this one by using the four AND gates only, since we have here four unique product terms. Now we got here four unique product terms. So now we have satisfied the condition which is given in the question that we have to design with the help of four AND gates only. Now we'll see that how we are going to design this one with the help of four AND gates. So for that purpose, again here we have taken the function, same function what we have here. Now that function having three variables. So we have variables is already given A, B, C. So those variables we are going to mark as A, B, C. And to obtain A and A dash, B, B dash, and C, C dash, we are using the buffer here. If it is connected without bubbles, it is A, with bubbles A dash. Similarly here, this connection B, this one is going to give us B dash. This one is going to give us C, and this one C dash. So now here, if you see in the bottom part here we are going to get this is A, this is A dash. This one is B, B dash, and C, we have C dash. Now, since in case of PLA, AND array and OR array both are programmable, so we are using the logic array symbol. So this first AND gate we are going to take for the product term A dash, B dash. So according to that, we are going to put the cross. This cross represents that fuse is intact. If only plus is there, it represents that fuse is gone. So we have A dash and B dash. Second AND gate we are going to take for A dash, B dash product term. So again we have A dash here, and now we have another literal C dash. Third AND gate we are taking for B dash, C dash. So we have connection here that at B dash we have cross, again at C dash we have cross. And fourth product term is ABC. So now at A we have cross, again at B we have cross, again at C we have cross. So you should keep in mind that whatever literals are given for corresponding on logic array wire, on that logic array line, we have to put the cross. Without cross, it is showing that fuse is blown. Now, if you see that we have four inputs AND gates. and we are connecting only 2 literals, 3 literals. So the port of the AND gate which is open, that is by default it is connected with 1. So whatever port is remain open for the AND gate, all ports are connected with 1. So now the first stage that we have AND array which is programmable, that we have implemented here. Now next task is to obtain the OR array programmable. So that's second stage, that is OR array programmable. So now again here we are going to use the logic array symbols. Since it is the programmable, so that's where using the logic array symbol. Now two functions are given here, one is f1 and another is f2. So since we have two functions, so number of OR gates are 2. So number of OR gates depends how many functions are there, and number of AND gates depends how many unique product terms are there. So now we have two functions, so we have two OR gate here. So one OR gate will use for the f1, another OR gate will use for the f2. Now suppose this one we are going to for the f1 purpose, this one we are going to use for the f2 purpose. So this is just like we are keeping in the mind. So this one we are going to take for f1, another we are going to take for the f2. So in the f1, what are the product terms we have? A dash, B dash, so that fuel should be intact. And we have A dash, B dash, again it is intact, so we are putting cross. And third one we have B dash, C dash. So now this OR gate is going to give the output, that is A dash, B dash plus B dash, C dash plus A dash, C dash. But actually F1 is what? Complement. Suppose for example, both functions are without complement. Then our design will be only up to OR gate. Okay. Here one function is with complement, so we are going to use the XOR gate also. Again, we have discussion, we'll discuss about this. Now second OR gate we are going to take for the F2. So now for this purpose, now F2 having what are the product terms? We have A dash, C dash. So that fuse is blown? No. That is cross means fuse is intact. So A dash, C dash is intact. B dash, C dash product term is available. So we have to put the cross. Again, we have third one is A, B, C. So this also should be cross. So we have marked the three product terms. So finally, this OR gate output is A dash, B dash plus B dash, C dash plus ABC. Now since one of the output, that is a function, is with complement, so we are going to use the property of the XOR gate. So in case of XOR gate, we have X XOR 0. X XOR 0 is what? X. If you have X XOR 1, that is going to give us X. That is the complement of the X. So similarly, now here we have two XOR gates. Since we have two functions here, one function is without complement, one is with complement. Now F1 is with complement. So here, from here we are going to obtain the F1. So this should be connected with 1. So this 1 should be crossed here, and this second XOR gate is going to give us F2. So here 0 should be in the intact. So we are putting the cross at the point. So like this, we are able to design programmable logic array with the help of AND array programmable and OR array programmable. And if functions are without complement, no need to use the XOR gate. Up to OR gate is sufficient. If in the question they will not mention that we have to use the limited number of the AND gates, then we'll not look for the complement of the function. We'll do the normal K map. Then whatever product terms are there, that we are going to implement. But for the design point of view, we are trying to minimize the number of product terms so that cost also will be reduced and it can be economical. So as per the given function, we can utilize the opportunities to choose how many variables are there and how many AND gates we are going to get, that is the product terms. And here in case of our programmable array, whatever ports are open, that input is considered as the 0. Since in case of OR gate, if any one input is high, output will be high. Whereas in the AND gate, if all inputs are high, then only output is high. So that's why it's taken here 1. What are the empty ports, open ports? That input is 1. In case of OR gate, what are the open ports? That input is 0. Thank you. Thank you very much. Like this, we can continue some other topics also. Thank you. Thank you.